Hello. Good morning, every students.
Sir.
Am I audible?
Yes, sir.
Okay, let's wait for 2 minutes so that the rest of the students join and then we will start the class. Why only 11 students has joined? Rest of all?
मैसेज किए सर, देख लीजिए। हम लोग का सीआर मैसेज किया है।
मैसेज किया है। जूम पे क्लास लीजिए, इस पे ज्वाइन नहीं कर पा रहा है, क्यों?
सर इधर प्रीवियस 2 दिन से सर टीचमेंट में सर हम लोग ज्वाइन नहीं कर पा रहे हैं मैक्सिमम को। तो उसका सर सर्वर के कारण कुछ एरर है।
I don't know, but maximum of the in this college have been participating in teachment, and the maximum classes has been done in teachment. So I don't know what is the problem. So
Sir.
let's see here. He's huh? Anjan Kumar Vishwakarma. Anybody could tell?
यस सर, वही सर, कल से टीचमेंट का सर्वर थोड़ा डाउन है सर, इसलिए लोग ज्वाइन नहीं हो पा रहे थे, इसलिए बोले। सुनिधि मैम
आप
भी सुनिधि मैम को भी जूम पे ही लेना पड़ा क्लास, वो भी टीचमेंट पे ही लेती थी।
ठीक है, तो जूम का मैं क्लास आज दे रहा हूँ, पर मैं बोल रहा हूँ कि आप कौन सा डिपार्टमेंट का है?
सीएससी सर।
ठीक है, तो मैं शेड्यूल दे रहा हूँ आप लोगों को अभी।
पर सर आपका क्लास में शायद लगभग स्टूडेंट आ गया है, शायद अभी ठीक हो गया होगा। ले सकते हैं सर इसमें क्लास आप।
ठीक है, तो नेक्स्ट दिन से अगर प्रॉब्लम होगा तो थोड़ा पहले जना देना, तो हम आपको जूम का क्लास दे देंगे, ठीक है?
ओके सर।
Okay, so let's start the class. 20 people has joined, and let's start the class. Today we will discuss about the special purpose diode, because we have covered all the diode section. Last day we have discussed about the Zener diode and all the things, and we saw that Zener diode is working as a voltage regulator, and we had to do the numerical problems on that Zener diode also. So today we will discuss about sub special purpose diode. Actually, the most common application of diode is rectification. But rectified diodes are used in power supplies to convert AC voltage to DC voltage. But rectification is not all that diode can do. A number of specific types of diodes are manufactured for specific applications in this fast developing world. Some of the more common special purpose diode are Zener diode that we have already discussed, light emitting diode that is called LED, next is photodiode, another is tunnel diode, another is varactor diode, and the last one is Shockley diode. There are all more different types of diodes, but especially we will learn about, or moreover we will learn about this all the types of diode. And today we will discuss about LED, that is light emitting diodes. Then we will discuss about our photodiode, tunnel diode, varactor diode, and Shockley diode. So these are the diodes that we are going to discuss. So before continuation of this today's chapters, let me ask one thing, that most of the diode portion is completed. So have you anyone having some problem with the diode or the numericals that I do in the class, or you have some problem while solving any numericals? So you can tell me, because uh, what we need some means, if there is some problem I can know, because this is very much important for us, so that because we have already done our diode, and this is a little bit repetition from madam what madam has taught, and this is the I will tell a little bit repetition on this course. And then also if you have some problem, then I want to know from you that if any problem is there, you can tell me. Anybody, any problem? So there is no there is no problem, I think, because there is no response from your end. So I think it is okay for you. I will request everybody, if you have some problem while solving any numericals, please upload that problem in the teachment platform so that I could see and knock me that I could see it and I could solve it. If there is any type of problem you face while solving the numerical subdiode and all that thing, then you must Jenner diode numericals also. We have discussed for Jenner diode numericals. So if there are more numericals, there are more type of numericals. So if anybody will face any type of problem while solving these numericals, it is my earnest request to you to please know me about that problem. Okay, so thank you. Let us start today's topic that we have already told you that we will start today. That is the special purpose diode. And in special purpose diode, today we will discuss about some of the uh, just a minute. Just a minute. Give me a second. So today's date is 19th January 2022. Special purpose diode. So first is light emitting diode, or it is also known as LED. If we draw the symbol of this diode, This is a symbol of the diode. And when it is forward biased, the internal schematic diagram is represented like this. So this is the internal structure. This is P, this is N. This is positive. This pin structure is negative here. Okay. So this is the recombination is holding here. This is emitted visible light. So this is the figure. Okay. So now let's go to the theory portion. Just a second. I mean, a light emitting diode is a diode that gives off visible light when it is forward biased. Light emitting diodes are not made from silicon or germanium, but they are made by using elements like gallium, phosphorus, and arsenic. So these are made of gallium, phosphorus, and arsenic. LED are made up of. By varying the quantities of these elements, it is possible to produce light of different wavelengths with colors that include red, green, yellow, and blue. For example, when a lead is manufactured using gallium arsenide, it will produce a red light. If the lead is made with gallium phosphide, it will produce green light. Understand? So when the light emitting diode is forward biased, as shown in this figure, the electrons from n-type material cross the pH junction and recombines with holes in the p-type material. These free electrons are in the conduction band and at higher energy level than the holes in the valence band. So when the recombination takes place, the recombined electrons release energy in form of heat and light. In germanium and silicon diode, almost the entire energy is given up in the form of heat and emitted light is insignificant. That means the entire energy for silicon and germanium is insignificant. But in these materials like gallium arsenide, the number of photons of light energy is sufficient to produce quite intense visible light. Understand? The arrows are shown as pointing away from the diode, indicating the light is being emitted by the device when forward biased. Although LEDs are available in several colors, red, green, yellow, and orange are the most common. The schematic symbol is same for every LEDs. There is nothing in the symbol to indicate the color of the particular LED. And if we show the graph of the between the radiated light and the forward current of LED, it will be clear that the intensity of the radiated light is directly proportional to the forward current of the LED. Okay, so if I show you the graph, let us show you the graph. So if I show you the graph, if this is the x-axis and this is the y-axis, and y-axis is the radiated light, radiated light, which is in milliwatt. আবার খুলেছে। And this is forward current, that is in milliampere. Then if I give the values 0, 20, 40, 60, 80, 100, and this here 2 milliwatt, 4 milliwatt, 6 milliwatt, 8 milliwatt, 10 milliwatt, and 12 milliwatt. So you will see Just a minute. It will be like this, a straight line. So it is clear from this graph that the intensity of the radiated light is directly proportional to the forward current of the lead. So intensity is directly proportional to IF, that is of lead. So if we talk about lead voltage and current, then if we draw the circuit diagram, so here will be a resistance, here will be the supply voltage, and here will be the diode. So this is denoted by Vs, this is Rs, and this is Vd, and there is a current flowing, there is forward current flowing through this, and that is If. So the forward voltage ratings of most lead is from 1 volt to 3 volt, and the forward current rating range is from 20 milliampere to 100 milliampere. So I forward current rating, IF rating, that is equals to 20 milliampere to 100 milliampere. Okay, and forward voltage rating is, that is equals to 1 volt to 3 volt. In order that current through the lead does not exceed the same value, the resistor Rs is connected in the series. The input voltage Vs and the voltage across lead is Vd. So voltage across Rs equals to Vs minus Vd. So circuit current, that is If, equals to Vs minus Vd by Rs. Okay, everybody clear?
Yes, sir.
Okay. What is the advantage of LED? Number one, the light emitting diode is a solid state light source. LED has replaced incandescent lamp in many applications because they have the following advantages. What are the advantages? Number one, it is low voltage. So the 2D bulbs or other bulbs that produces the lights have much more voltages. Then it has a longer life, more than 20 years. So if you invest one time for a LED bulb, it will be more sustainable. That means long time investment will be very good for it. And fast on off of switching. The switching circuit is very fast. Okay. So that are the advantages of LED. That's why LED is been used as a solid state light source, and it has been replaced the incandescent lamps in everywhere.
सर यहाँ सबसे नीचे में आर एस इजिकल टू वी एस माइनस वी डी लिखे ना सर.
IF RS
नहीं, उसके
equals to VS.
लेफ्ट
हाँ,
लेफ्ट में
RS
सर.
RS equals to VS minus VD. That is the voltage across. Voltage across RS equals to Vs minus Vd. And this is the circuit current. This is the circuit current. Okay, so कभी कभी न्यूमेरिकल आ जाता है छोटा छोटा. So I think it will be solving by you, no problem. जैसे कि मैं एक एग्जांपल दे रहा हूँ आप लोगों को. छोटा एक न्यूमेरिकल, एक दो लाइन का न्यूमेरिकल आ जाता है कोई कोई. तो उसके लिए आप लोगों को थोड़ा प्रस्तुत होना चाहिए. तो एक एग्जांपल मैं दे रहा हूँ आप लोगों को, समझ सकते हैं. बहुत ही आसान सा न्यूमेरिकल है. जैसे कि यहाँ पर मैं डिस्कस कर रहा हूँ, व्हाट इज करंट थ्रू द एलईडी in the circuit shown in the below figure. Assume that the voltage drop across the lead is 2 volt. So what is the circuit diagram? This is the power supply. This is a ground. This is 2.2 kilo ohm. This is the forward voltage IF. This is 15 volt. There is the lead. It is also connected to ground. So the solution. Current through the lead IF equals to Vs minus Vd by Rs. Now here,
सर आंसर है 0.005 एम्पियर.
yes, Vs equals to 15 volt, Vd equals to 2 volt, Rs equals to 2.2 kilo ohm, that is equals to 2.2 into 10 to the power 3 ohm, sorry, minus 3 ohm, uh, kilo ohm থেকে ohm, minus 3 no, plus 3. That is equals to 1 by 1 F, or forward current IF equals to 15 minus 2 by 2.2 into 10 to the power 3. That is equals to 5.91 into 10 to the power minus 3 ampere. That is equals to 5.91 milliampere. So that is the answer. So like this problem will come in the examination, and I don't think there will be much more problem for you to solve. Like one question is there, what is the value of the series resistor is required to limit the current through a lead to 20 ampere with a forward voltage drop of 1.6 when connected to 10 volt supply. That means what? Supply voltage is 10 volt. Then what is told? Forward voltage drop, that means Vd. Vd is equal to 1.6 volt. And we have told to limit the current through the lead to 20 milliampere. That means current through the lead is 20 milliampere. So one forward current is 20 milliampere. So IF is equal to 20 milliampere. So that is 20 into 10 to the power minus 3 ampere. So from the formula, what Rs is equal to? Rs equals to Vs minus Vd by If. So I put the values. Rs is equal to Vs minus Vd by If, and I put the formula here. So if I put it, what I will get? That is equals to 420. So the resistor Rs is current limiting resistor, so the resistor Rs must be equals to 420 ohm, so that it will allow only 20 milliampere current to flow through the circuit. That's why sometimes RS is called what? RS is called current limiting resistance. Current limiting resistor. Okay. So that is from the lead. So I think everybody has understand the lead.
Yes, sir.
Okay. So where we use lead in our electronics application as a power indicator. As a power indicator, we use the lead. Next, in the 7 segment display, when you will use a digital 7 segment display, then 7 segment display so is used as a lead. Okay. So next, our special diode is photodiode. Next, our special diode is photodiode. So photodiode. Photodiode is a reverse bias silicon or germanium PN junction in which reverse current increases when the function is exposed to light. The reverse current in a photodiode is directly proportional to the intensity of light falling on the PN junction. So what is for photodiode? It is a reverse biased Si or germanium PN junction in which reverse current increases with the junction is exposed to light. Okay. The reverse current in a photodiode is directly proportional to the intensity of light falling on it. So, reverse current reverse VR current is directly proportional to the intensity of light falling on its PN junction. Okay. This means that greater the intensity of light falling on the PN junction of the photodiode, the greater will be the reverse current. When a rectifier diode is reverse biased, it has a very small reverse leakage current. The same is true for a photodiode. The reverse current is produced by thermally generated electron hole pairs which are swept across the junction by the electric field created by the reverse voltage. In a rectifier diode, the reverse current increases with temperature due to the increase in number of electron hole pairs. A photodiode differs from the rectifier diode in that when its PN junction is exposed to light, the reverse current increases with the increase in light intensity and vice versa. When the light, that is the photons, falls on the PN junction, the energy is imparted to photons, to atoms in the junction. This will create more free electrons and more holes. These additional free electrons will increase the reverse current. As the intensity of the light incident on the PN junction increases, the reverse current also increases. In other words, the incident light intensity increases the resistance of the device. Increases the resistance of the device, decreases. Okay.
Okay, sir.
Now, I will tell one thing. Semiconductor devices such as diodes and transistors are usually enclosed in an opaque case to protect from the light because there is a temperature effect. But these light detecting devices like the photodiodes or LDR, light detecting resistors, those light detecting things are there. Due to there is a intensity, that means if the light will fall more intensely, the reverse current will increase and that will help in etc for the photodiodes and photodetectors like this. So that transistor and diodes which are used for light detecting on must be encased in transparent plastic or glass. So you will see the normal diodes are means what I will tell are enclosed in a opaque case. You will when you will get that diodes in your hand, you will see it is the means the composition is such that the light will not fall or that light will not affect. That's why opaque things, opaque materials are used to do the outer body or to make the outer body. But in detectors or light detecting diodes, it is made of glass or made of transparent plastic so that light could fall on them and the intensity of light must increase. You will see that LED bulbs, small LED bulbs that are used for our experiments are made up of transparent plastic so that the light can fall on it. Okay. So schematic symbol of photodiode and the typical photodiode, how it will look like. I will give you the example. Actually, the photodiode will look like this. Just a minute. So this is looking like a photodiode. Okay. There is another circle in the upper portion, and there is a ring in the lower portion. Okay. And there are two anodes. Odes are there. One is anode and another is cathode. Little bit like this. Okay. This is anode. This is cathode. Okay. And this blue color, this is called the window where the light will fall. And if I draw the diagram schematic, same as diode symbol, for LED it is going away, for photodetectors it is, or photodiode it is coming in. That means intensity of light is falling. This is cathode and this is anode. So if I draw the circuit, there is the supply voltage. This is the resistance. Okay, this is reference R, this is V, and this is IR. So you can see it is reverse biased. The circuit has reverse photodiode, resistor R, and a DC supply. The operation of the photodiode is under when no light is incident on the PN junction of the photodiode. The reverse current IR is extremely small. This is called dark current. Okay. The resistance of a photodiode with no incident light is called the dark resistance. RR is called the dark resistance. And IR is called the dark current. So we can write RR equals to VR by dark current. Okay. When light is incident on the PN junction of the photodiode, there a transfer of energy from the incident light, that is photons, to the atoms in the junction. This will create more free electrons and more holes. These additional free electrons or holes will increase the reverse current. As the intensity of the light increases, the reverse current IR goes on also increasing till it becomes maximum. This is called saturation current. Okay, so that is our photodiode. Application of photodiodes. Applicable of this photodiode will be in alarm circuit. Then we can use also it is in counter circuit. Okay. If you connect this photodiode in a doorway and there is a light source and light beam and photodetector is there, then whenever any obstacle will pass through the doorway, it will be connected with the alarm and the alarm will ring because photodiodes will detect the photons. So whenever there is a dark, that means obstacle, there is no light falling to it, it will be not operating, and that circuit will be break, and that time the alarm will goes ring. So that will be that you can also use. Okay.
Yes, sir.
So if I draw the graph one is against IR, that is reverse, reverse current. I small r is the dark current, and I capital R is the reverse current. So IR versus E first. E is what? Illumination. E is called the illumination. E is called the illumination. That is our E. So if I draw it, this is 0, this is 1, this is 3, this is 10. This illumination, the unit is milliwatt per centimeter square, and IR will be in microampere. So this is 10, this is 30, this is 100, like this. Okay. So what will we do? We will do get like this. Get like these values. It will be a straight line. Okay. The graph is the straight line passing through the origin. So I will get IR equals to M into E. So where M is equals to slope of the straight line. Okay. The quantity M is called the sensitivity of the photodiode. And another graph is there, that is IR versus, that is microampere, versus VR, that is in volt. That is reverse voltage versus reverse current curve. So what will the output we will get? We will get like this. So this is 0, this is dark current. This is E equals to 200 LUX, and this is E equals to 400 LUX. Okay, so these are the two graphs. So that is photodiode. No problem with this, I think. Any problem? Photodiode?
नो सर। सर एक क्वेश्चन था।
बोलो।
सर जो सीडी ड्राइव जो रहता है सर,
हाँ,
तो सर उसमें जो सर सीडी अगर रीड करता है तो सर वो कैसे सर होता है सर? उसमें कौन सा मतलब यही
उसमें
रहता है क्या सर फोटो ड्राइव?
नहीं, फोटोडायोड नहीं, वहाँ पर ऑप्टिकल रहता है। वो ऑप्टिकल क्या करता है, ऑप्टिक्स जो रहता है वहाँ पर एक लेंस रहता है। वो लेंस अपना जो अपना सीडी ड्राइव मतलब वो तो मैग्नेटिक ड्राइव है, तो वहाँ पर जो बिट्स मतलब वो राउंड डिस्क में कुछ एन्क्रिप्शन रहता है, तो वहाँ पर वो लाइट पड़ता है, और लाइट पड़ने से उसका जहाँ जहाँ पर एन्क्रिप्शन है उसके ऊपर एक हीटिंग इफेक्ट पड़ता है, और वो हीटिंग इफेक्ट एनर्जी में कन्वर्ट होकर तुम्हारा वैल्यू देता है। So that is optical. That is also optical one, but that is not a diode. That is optical device. That's why it is like what I will tell. It will be understandable more. Most of you will understand that in optoelectronics, optical communication, optoelectronics devices, and that is an optoelectronics devices. Like we today use the bandwidth, means broadband. In OFC cable, we told that OFC cable, optical fiber cable. So that is also using the method of light, because it is optics. Optics is optics always depend upon the lights, but that is different one. Optical source, that is also for optical lens, that is also related to LED or optical detectors. Everything is related because the light will be transported into a heat energy, or the photons will be transported into the atoms. That principle is same for everything. The intensity and all that thing is same, but a little bit difference. That's why these all are called once LED, photo detector, all these things are called are optical devices. So same but not fully same.
ओके सर।
Okay. Next is our tunnel diode. To understand tunnel diode, what is a tunnel diode? Tunnel diode is exhibits negative resistance between of edges, that is between peak point voltage and valley point voltage. What are these? Actually, it is a PN junction exhibits